engage in diverse carbon inputs on your farm as dictated by your analysis, and you'll be successful. In other words, if your plant is showing severe carbon deficit, you're probably going to need heavy, strong, large carbon molecule based biopesticides to pair with that, because you're probably going to have some degree of crop pest, right? In these carbon depleted environments, there's huge amounts of, much greater pest and disease pressure, generally speaking. We can get the carbon to nitrogen balance. The plants are going to create optimal microbial environments themselves. If we have higher levels of carbon from the environment and also released from the soil, we're going to have greater acceleration of plant photosynthesis. So I can't stress carbon enough, and to really encourage you to just engage in diverse carbon source inputs. Almost every time you put out some degree of a crop input, it has to include carbon. Nature does. So when you're looking at soil applications, right, so you always want to start with your quantitative data. Then you want to look at what type of application are we doing. Are we doing a drip application? Are we doing a pivot application? Are we doing a foliar spray? Are we doing a bulk dry granular? That's going to drive your input selection, your rate, compatibility. For those of you that are consultants, you're obviously well versed in doing jar tests. If you're not, I would encourage you to understand how to do compatibility and jar tests. If you need to do enhancement, that would be referred to as, taking a microbe or taking a fertilizer and enhancing it through a deliverability input, matching that to the type of equipment that's going to be applied, and then recalibrating your rate based on that equipment. Sometimes, you might say, all right, well, we want to put out, 15 gallons of total input, but then our actual spray volume is only 15 gallons. So then you need to revise that in order to make sure that it rides well with the equipment. Last but not least, the calibration that goes alongside applying those nutrients at the appropriate timing. And so this is really just a play on and a little bit more of a deep dive on the 4 R's of nutrient management that the American Society of Agronomy recommends. But we're actually going a little bit deeper into the evaluation and the application matching. This slide is a repetitive one because it's important for folks to understand, again, the different categories of crop inputs, how to assess a crop input in the marketplace and put it into its correct pot so that it can be evaluated and compared against similar crop inputs by price point, by efficacy, by matching your crop goals and your grower goals to your crop input types. So, in other words, if you're regenerative but not organic, your carbon conventions conventional, your carbon complex conventional, versus if you're organic or regenerative, you don't want to really focus on, how do you ramp up and access the most amount of microbial activity to provide long-term residual benefits, because obviously organic fertilizers are more costly on a pound per pound basis. Doesn't necessarily mean they're costly on more costly on an efficacy basis. So again, I can't stress this slide enough because there's a lot of different inputs out there and a lot of confusion about, what growers are going to expect from the application of one or another. A couple of different checkpoints along the way. If you're looking at leaf or versus soil for your analysis, your jar test, your penetrometer, soil respiration, organic matter on both total and soluble, acidity, bicarbonates, anions, cations, starting to wrap your head around how those are impacting your crop. Work with a trusted advisor that has insight into this approach. Qualitative outcomes, your whole plant visible look. If your plant doesn't look appropriate or doesn't look like it's responding, deeper analytics oftentimes is helpful to get you over the hump, right? Insects, disease, variations and changes in your NDVI, visible structure, visible color. All these are indicators, well, hey, something's off. Let's do analysis and let's get to a better understanding of how we can solve our problems. And so again, the goal of soil analysis is to essentially replicate Mother Nature's processes within our own capabilities to inform our farms and our farm environments in the proper way. And by inform, I mean here's an input that's going to allow this crop to perform better, but it's been informed that this is the direction that you want to grow, right? So we're informing the field that we want to grow it in an organic way through our actions, or we're informing it we want to grow in a regenerative way or a conventional way because that's what we have through our capabilities, through our mechanics, and so on and so forth. And so there's a vast difference between a lot of different types of soil analysis. Those correspond in a certain degree to different types of inputs, and those also correspond to different goals for the grower of outcomes. And when you all three of these are in alignment, you're going to have a much better chance at saving time, saving energy, saving your budget, achieving the appropriate crop outcome, and achieving the appropriate mechanical effectiveness on your farm. Carbon is king. Thanks again very much, and look forward to seeing you all next week. Take care.